Okay, so I want to have a look at two more definite integrals here quickly, just basically to familiarise you with these different limits, because I didn't make it clear before that the limits can actually take any number. Again, they're both quite easy integrals to do, and they've only both got single terms. Of course we could have, huge long polynomials where we're going to integrate as well, but just for the sake of saving paper and to simplify the point, just using a single term each time. Okay, so let's have a look at the first one. Now remember, the first thing we do here is we integrate, we put it in these big square brackets. Okay, so this first one is going to become, well, 3x, that's actually 3x to the power of 1. If you add that 1 to that, it becomes 2. So we've got 3x squared, and then we divide by the new power, so we get 3x squared over 2, or 3 over 2x squared. Okay, remember, no c, because you don't need a c in a definite integral. Okay, why is that? Well, think about it. What would happen if you did have a c when we do the subtraction? Anyway, I'll write the limits in as we said, and then we can evaluate this below. So we put x in as 2 first, so we've got, and I'm going to use square brackets again here, just so I don't get confused with all my different brackets. Okay, so I've got 3 over 2, and then I've got 2 in, 2 squared, and then from that I'm going to subtract 3 over 2, and I'm putting not 2 this time, but 1 as the lower limit. Okay, and then 3 squared is 4, times 3 is 12, divided by 2 is 6. So I've got 6, and then 1 squared is 1, and then 3 over 2, so that's minus 3 over 2. 6 minus 3 over 2, well, 3 over 2 is 1.5, so that's 6 minus 1.5, well, that's 4.5. So my answer here is 4.5. Okay, see, imagine if I had a c here, plus c here, minus, plus c there. So the c would cancel out. That's why we don't need to write the c in the first place. Okay, next one. I haven't left myself a lot of space for it, but it's fairly straightforward. So 2x cubed is the integral to compute. I'll do it a little bit lower. Add 1 to the power, so it's 3 goes to 4. 2x to the 4, and then divide by it, the new power, so that's 2x to the 4 divided by 4. Okay, of course that actually simplifies to give you x to the 4 over 2, and that has limits of 3 and 0. Okay, so we just do that here. I'll cancel that and cancel that, and right, there's a 2. So I've got x over 2 to the power 4. Now, I'll put 3 in first, okay? So here I'm going to have 3 to the power 4 over 2 minus 0 to the power 4 over 2. Okay? And obviously this whole thing here is 0, because 0 to the 4 is 0, divided by 2 is still 0. So I'm only interested in this 3 to the 4 over 2. Okay, now be careful here, it's only the 3 that's raised to the 4, not the 2, because the 2 is underneath, and the 4 only applies here to the x. So 3 to the 4, that's 3 times 3 times 3 times 3, so that's 9 times 9, 81. 81 over 2, and 81 over 2 is our complete answer here. Okay, this whole put is 0, so there's no need to write that in, so it's just 81 over 2. So there we go. I mean, it's not too difficult, these definite integrals. We just integrate, put the numbers in, put the top one in, then subtract the bottom one as it in. Okay, in the next video I'm going to go through some of the questions on that sheet that I asked you to do on Friday. Okay, alright, well till then, see you later.